It's like March 5th and then 5 years. You know?
Oh, yes.
It's like that's your gold anniversary. No, I'm not kidding.
Yeah. All right, exponent review. What we're doing in Unit 9 is exponents and logs. Exponents is a parent function. 2 to the power of x is the exponential parent function. Separately, logs are a parent function. So in Unit 9, we study them both because they are exact opposites of each other. It's kind of like love and hate are the same, and indifference is the one that's completely different. You study opposites in math always together. So we're going to study exponents at the same time logs. I'm not separating the two. Tomorrow we're going to get into logs, and we're going to use exponents just as much as we do logs because they are one and the same. But we got to kind of recall some of these properties before we just dive into logs with exponents. So the properties that you learned in Algebra 2 were about what happens if you multiply x to the a times x to the b. What do you do with those powers? You add them. So this is going to be x to the a plus b. Back in Algebra 1, maybe in Algebra 2, they showed you the y, and they even encouraged you to do the y. It's because if you have x squared times x cubed, what you really have going on is x squared means you have x times x. Meanwhile, x cubed means you have x times x times x. So when you look at how many x's you have x to the 5th. And so that's how they introduce the idea, but I mean, you're not going to want to be writing out 5 x's every single time. So the shortcut is to add. So I could do the same thing if you are dividing. Dividing is the opposite of multiplying. So subtracting is the opposite of adding. So I'm going to do x to the a minus b. And I could show you the same thing, put some x's on top, put some x's on bottom, show you how they cancel, and they end up that way. Anything to the 0 power is 1. X to the a times y to the b, all raised to the n. So, say it again, Rachel.
X like to the a and
Good. So this is really like x to the a to the n and y to the b to the n.
it's like where'd you get that?
But you would never leave a term raised to an exponent, raised to another exponent. What do you do with exponent to exponent?
Add them?
Multiply.
Oh.
So the final thing that you would be looking to do here would be x raised to the a times n, y raised to the b times n. And the reason why we do that is because, for example, if I told you what is 2, or if I asked you 2x squared to the 3rd power, that would be you're taking 2x squared 3 times. 2x squared, 2x squared. So what you really end up doing is doing 2 times 2 times 2. Well, that's 2 cubed. X squared, or x squared times x squared times x squared is x to the 6. Well, that's x to the 2 times 3. So it's really the same thing as polynomials. We just have these shortcuts that allow us to go a lot faster than actually writing out this stuff. X to the negative a, we don't like negative exponents, so we will flip it. So 1 over x to the a. So it doesn't matter if that negative's on bottom or if that negative's on top. You don't like negatives. So this negative that's on bottom now needs to get moved to the top. And if you want to write over 1, great. All right, so let's practice our simplifying. So on A, x squared y, all cubed, times 5x to the negative 1, y to the 4th, all squared. So this is one of those properties where you have something in parentheses raised to the 3rd power. So that 3rd power is going to, so to say, distribute to both of these inside pieces. And when you distribute to the x squared, that one's fine. You see the 2, you know what you're going to do. What is the exponent associated with the y currently?
1.
Just a 1. If you want to write that 1, I think it's good practice until you get really used to what you're doing. So now I see I have x to the 2 to the 3. I multiply, so that's x to the 6.
I get confused when you add the exponents when you multiply them.
And y to the 1 to the 3 is y to the 3.
Okay, so
You multiply if you have exponent with an exponent. I'm going to keep that in parentheses. I like parentheses. Okay, now I have to do the same thing to the 2. How many terms are in this set of parentheses, though? 3. The 5 is a term. It deserves to be squared as much as everything else. X to the negative 1 is going to get squared. Y to the 4th is going to get squared. So again, if you want to write a little 1 right here, it really helps you remember that it's going to end up being 5 to the 1 to the 2. So 1 times 2 is 2. So it's going to be 5 squared. I am doing this in very elementary steps. If you want to skip that step and say that's 25, that's fine. I'm just doing this how I'm doing this. X to the negative 1 to the 2 is x to the negative 2, and y to the 8. So I am going to take a step really quick and just write 25 instead. So this is x to the 6, y to the 3, 25, x to the negative 2, y to the 8. It is usually my preference to wait to fix negatives until the very end. I'm not going to say it's always my preference. There are some exceptions to that. But I'm not going to change x squared. I'm not going to put him on bottom. Because what I'm about to find out is with this x to the 6 and this x to the negative 2, this is when you would add 6 plus negative 2 and you get 4, which is positive. So just by taking that step of adding these exponents, I don't really have to consider this guy on bottom. It just kind of works itself out. I also have that 25. He's a loner. He doesn't have anybody to multiply. X to the 4th is my new x power, and y to the 11 is my y. Okay? All right, B. 36, x to the 4th, y to the negative 2, over 24, x to the 7, y to the 4. What would someone like to do first? Simplify how?
the negative 2 and the 4 and the 4 and 7. Or 36 and 24.
Yeah, it really doesn't matter. I heard a couple of different things. If you wanted to move the y to the negative 2 down to the bottom, you could do that. Again, I kind of think that's an unnecessary step, but if you want to, that's fine. When I see this, I generally just go in left to right order. So I would start with my numbers. How does 36 over 24 going to simplify? What number divides them both?
83 or 12.
Go as high as you can. 12. So if I take both of those numbers, divide by 12, 36 divided by 12 is 3 over 2. Okay, what about x to the 4, x to the over x to the 7? How am I going to simplify those?
You get x to the 3 on the bottom.
Why is it on bottom?
There's more on bottom.
Yeah, a whole bunch of y'all are saying when you subtract the 2, you get 3. And since the bigger number was on bottom, it's going to belong on bottom. If that's your style of remembering this, that's fine. Danielle said, when you do 4 minus 7, you get negative 3. But you know you're not allowed to end with negative 3, and so then you would move it to the bottom. It doesn't matter how you do this. It is completely up to you as long as you do it correctly. Okay? All right, so y to the negative 2 over y to the 4. Be careful with your subtraction. Negative 2 minus 4 is negative 6, so where's y to the 6 going to belong? On bottom. There's nothing more to do. That's your final answer.
On example A, was it plus y to the 11th?
Just times. Why would you get plus? Okay. Okay. All right. C and D are really supposed to be done together, or not together, but you're really supposed to be comparing these. So I want to put a big versus. Negative 3 to the fourth versus negative 3 to the fourth. Those are two completely different things because in example C, you don't have those parentheses. And what the parentheses tell you is where to start your exponent and where to end your exponent. If you don't have a parentheses, you have to assume that this 4 is only dealing with the 3. So 3 gets raised to the fourth. Only 3 gets raised to the fourth. So 3 to the fourth is 81, and that negative is still there because nothing happened to him. He did not change. As opposed to negative 3 being raised to the fourth, now you're saying, well, I have negative to the fourth power. What's going to happen with negative to the fourth power? It's going to go away. It's going to become positive. And then you just have 3 to the fourth as well, and now it's positive 81. I really consider the negatives to be separate from the numbers. But if you want to say, well, what's negative 3 times negative 3 times, that's fine too. All right, another thing that you did in Algebra 2 was these things called rational exponents. The reason why we study rational exponents is because they are going to replace our radicals. So rational exponents are a way to express radicals as exponents. Square roots, cube roots, anything with radicals was actually not originally ever a thing. Radicals were developed as an elementary way to introduce the idea of rational exponents because for your mind to see it as a completely different symbol makes a lot more sense. So when you see the square root of 9, you know exactly what that's meaning to do. You take what is 9 multiplied two things, you get 9, and it's 3 times 3. But rational exponents was the original way radicals were always written. And what rational exponents are is just a fraction as an exponent. And when you have a fraction as an exponent, the denominator is the root of the radical. So an x raised to the 1 over b, b is the root of the radical. So you have b root, and then 1 is the regular exponent, so it would be x raised to the 1, which we don't really need to write raised to the 1, but just to kind of get us in the habit, the denominator is the root, the numerator is going to stay as the exponent. It does not matter. I'm going to show you that in this next one. So on x raised to the a over b, again, b is the root, and x is being raised to the a power. Notice this word or. It does not matter if you say it's x raised to the a under the root b, or you could say it's root b root of x all raised to the a. It does not matter which one of those things you write. Algebraically, to perform an action, this is easier because it's usually easier to make a number smaller and then make it bigger. As opposed to here, you'd be saying, well, raise it to the exponent first, which is going to get you ultimately a really big number, and then take the root of it, which is hard to do. But it doesn't matter. Okay. All right, so on page 2, example 2, we're writing using rational exponents. So if I want you to use rational exponents, that means I don't want radicals. That is what that statement means, right? Using rational exponents says, I want to see exponents only. No radicals. So in A, I have the cube root of x to the first power, if you prefer to say to the first power.
I said something, but you didn't hear me. Why are you afraid to tell her? Like, oh no.
So I have a squared to the 1/3. What is 2 times 1/3? 2/3. So I have a to the 2/3 and b to the 1/3. What's the goal again? Write in radical form. So now I want to write this in radical form. What do they both have as a denominator? So it's a 3rd root. What's a going to be raised to? If you take out the denominator of 3, it's still getting squared. So a squared, Tara, b to the 1, or just b. I think that doing this method is easier. You could have from the very beginning said, well, I know that they both have this root 3, and you could have gotten here. And for this particular example, it really is just that simple. But on the last example, doing my method of distributing first makes a really big difference as to how easy or hard it is. So on D, I'm going to do 64. I'm just rewriting it because it's too small for me. 64, x to the 3rd, y to the 10th, all raised to the 2/5. So I'm going to do 64 to the 1 to the 2/5. So I have to do 1 times 2/5, which is 2/5. So I have 64 to the 2/5. I have to do x cubed to the 2/5. How do you multiply 3 over 1 times 2 over 5? 6 over 5, x to the 6/5, and y to the 20 over 5 still. 25ths. So it is going to be y to the 4th. And this is why my method of doing this is so much easier. If you would have tried to do it the other way, it ends up a little bit more difficult. 64 to the 2/5. It is 64 squared, and then there's the 5th root. Is that going to go down any? What is the 64? 2 to the, it's 2 to the 6th. So you cannot actually break this down. It's really tempting to, but it's 2 to the 6th is 64. So 64 to the 5th root is not really something you can do. So I'm just going to have to leave it. The only guy that I can actually simplify is this guy. He's going to become y to the 4th. But these guys have to stay with a 5th root. So I'm going to have a 5th root. Okay, so 64 is going to get squared. X is going to get raised to the 6th power. And then I have y to the 4th. Where would be the best place to write y to the 4th? At the front. It just kind of looks weird to put it afterward. Honestly, this is a mistake. It should have said 32 to the 2/5. So that's not really something that's going to come up. On page 3. So these are just really more examples. I'm not going to do all of these. I just want to kind of do as many as I think we need to. So let's go down to I don't like any of these examples. Let's make up a new one. So let's do negative, open, negative 2x to the third raised to the negative 4. So lots of negatives here. Any first ideas?
Add the exponents. No. So find the other person from notes.
Okay. What do you mean by parentheses?
Take care of everything in parentheses first.
Wouldn't you do negative 2x to the third first?
Okay. Sure. So
Becomes positive.
this negative is not part of the fourth power. So he's just outside. He's going to stay outside. I'm not changing him. But I am going to be changing the fact that negative 2 is going to get raised to the negative 4. So the fact that the exponent is negative, what does that tell us?
It's getting a little more like the number's getting smaller.
What is that going to do as far as the exponents go, though? It's going to make it a fraction, right? Because when we do x to the negative 2, you say that's 1 over x squared. So this is really hard for me to explain, but this negative, if it's getting raised to a fourth power, whether that fourth power is negative or not, that's just the negative right here is going to make it go to the bottom. But it's still an even power. So I'm going to have this negative raised to an even power. So is this negative going to stay there?
Yes.
No. This negative is going away. Then 2 is going to get raised to the negative 4. So I am going to have 2 that gets raised to the negative 4 and x that gets raised to the negative 12. So all I've essentially done is I've just taken care of the fact that that negative raised to the fourth power is going to go away. I do not like negative exponents. You don't like negative exponents. So we got to put this stuff on bottom. So I still have this negative on the outside. If I'm putting this stuff on the bottom, I now have 2 to the 4th on bottom. I now have x to the 12th on bottom. Remember, when you put them on bottom, there's no longer a negative sign anymore. If I put everything on bottom, what's on top? Right there's fine. 1. You have to have something on top. You can't just not have a top. And so a final answer here would be negative 1 over 16x to the 12th. So I just kind of put that negative inside. 2 to the 4th is 16. X to the 12th I can't do anything with. That's going to be one of the harder problems. Do y'all want to do more problems? Okay. Let's do more harder problems. I chose really easy problems on here. So let's do negative 3x squared y to the negative 3, 5x squared.
Simplify the 25x squared first.
Okay, so if you want to simplify this guy first, that's just going to be 25x squared. That's a good idea.
And then take care of the negative and just shift that.
See, I mean, I kind of was hoping that y'all would have... I really think that if this guy is negative, I would start by putting him on bottom. Because I think that's the easiest first step, is to say, well, that really means 5x squared, he's going to stay on top. So I have 5x squared on top. But if you want to go and already be writing 25x squared, that's fine. And then this guy is all going to go to the bottom. I really think that this is the easiest way to start the problem, because having a negative exponent on the outside is hard. having a negative exponent on the inside isn't quite as hard.
That negative 3 would be negative though.
What?
That negative 3 doesn't become positive.
No. It's this negative sign that's causing all of this to go to the bottom. I'm not actually changing this. I'm just putting it on the bottom because of this guy's negative sign. Okay, so this is 25x squared. And this is negative cubed is going to stay negative. 3 cubed is 27. It's going to be x to the 6, y to the 3. But I do have x squared on top, and I have x to the 6 on bottom. 2 minus 6 is going to be negative 4. So that x to the 4th is going to go to the bottom. So 25 over, I like the negative outside, but it doesn't matter. Final answer. It's a lot of practice with exponents. But hopefully this is the 3rd year you've done exponents. I mean, it is going to be the hardest, but just try to do the best you can on tonight's homework. Quiz. This is going to be 2 minutes. So my recommendation for you to study or to make sure you can do it is to kind of make up some examples. Maybe Monday I'll give y'all like a practice one y'all can do. Set your phone to 2 minutes and make sure you can do them all. They are going to be grouped by squares and by cubes and by fourths, but they are not going to be in order. So like these are all in order, 1 squared, 2 squared, etc. They're going to be jumbled like how you see here. But all the squares will be in one place, all the cubes will be in a separate place, so it kind of does allow your brain to make a little bit of sense of things, okay? All right, I'm going to fill these in. I'm going to fill them in pretty quickly. This is 1, 4, 9, 16, 25, 36, 49, 80, 64, 81, 100, 121, 144. That's probably most of y'all's... at least that far. 169 is 13 squared. 196 is 14 squared. I remember that by just flipping the 6 and the 9. But when you don't write it in order, that doesn't really help. So I don't really know. But you got to memorize it somehow. 225, 400, and 625. Okay? The cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. 5 cubed is 125. These we've talked about and used frequently enough that hopefully they are in your brain. 6 cubed is 216. 7 cubed is 343. 10 cubed means there's 3 zeros. The fourths. 1 to the 4th is 1. 2 to the 4th of 2 cubed, thank you, was 8. 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th, 16 times 16, so 256. 5 to the 4th is 625. Notice that these two are the same, so if you keep that in mind, that might help you. 10 to the 4th is 4 zeros. All right, perfect fifths. 1/5, still 1. 2 to the 5th is 32. Something I left off that absolutely needs to be on here is 2 to the 6th. And that is going to be, if 2 to the 5th is 32, 2 to the 6th is 64. It does go that high, so you do need to be prepared for that one. I'm not going to fill in the example for the quiz. Y'all can just do that on your own. Down here, I talk about why I make you do this. And it's simply because we're going to use it all the time. It's not something that, it's going to be a calculator and a non-calculator test. And there are going to be things that I would just expect you to know. And these are them. More than using the actual exponents, I usually use the roots. This is usually why I need to know this more than actually knowing the exponents. Because if you know that 5 to the third power is 125, then you really also know that the cube root of 125 is 5. People don't memorize cube root of 125 is 5. People memorize 5 to the third is 125, so the opposite of that is that cube root of 125 is 5. It's a lot easier to memorize this than this. So these are just practicing the rest of these. Cube root of 27 is 3. Cube root of 343 is 7. This should say 6th root of 64. Sorry, that's my mistake. 6th root of 64 is 2. 5th root of 1 is 1. What is the implied root here? 2. This is implied square root. If you don't see that 2, it is there. It's just the most common of all roots, so they don't write it. So the square root of 625 is 25. Okay. So your quiz is Tuesday, March 5th.
So
Next Tuesday, 4 days. And in case you are wondering, it's also my wedding anniversary.
Aww,
So, pretty special day.
what year is it? How long?
Numero 4.